So I'm delighted to welcome you to the panel that is going to look at alternative propulsion systems beyond the internal combustion engine. And we're going to talk about wind, batteries, nuclear, and fuel cells. Nick Brown from Bureau Veritas is going to moderate this panel and introduce our panelists. I'd like to thank you all for joining us today to what is a very, very interesting panel and a very interesting topic. So Nick, I will let you introduce everybody and thank you again for being with us.
Nicholas, thank you very much. Great to see you again. And, thanks for inviting me to take part. So good morning, good afternoon, and good evening, wherever you are in the world, as we continue our meetings and interactions enthusiastically on Zoom, but maybe still wishing, of course, that we're going to see each other soon. I'm Nick Brown, Brand and Communications Director for Marine and Offshore at Bureau Veritas, where we're really interested and active in helping support the development of our subject today, the new propulsion systems that we hope will help shape the future of shipping. Just last month, we released our own new rules for wind propulsion systems. We have exciting projects underway for wind, for different types of fuel cells, and we have many electrical, hybrid, and battery-assisted ships that are in the water already to BV class and operating very nicely. We're also looking keenly at atomic power and the opportunity to apply our nuclear expertise to merchant shipping. So it's a particular pleasure to be moderating this panel, looking at alternative propulsion systems today. Decarbonization, of course, is the key subject of our times, so a very important subject, being brought to the table by Capital Link. And while many are hoping that new fuels of the future to power an internal combustion engine will save us, what about the alternatives? I think one of the key themes for this panel will be that if we are entering a future of new fuels, we're also entering a multi-propulsion technology future. And that the panelists we're going to hear from today present a very good cross-section of the new tech coming our way. They're all actively doing things. And I think all of these guys here today would share the feeling that it's not a zero-sum game. They're not fighting each other, that there's a space, I think, for a lot of overlap at the very least between different technologies, and they can work together. So our panelists today are Mr. Kim Diederichsen, who is the CEO. We have 4 CEOs today, the CEO of Anemoi Marine, Mikal, the CEO of Core Power, Guy Bjørkeli, the CEO of Corvus Energy, and Vasilis Gregoriou, CEO of Advent Technologies. So welcome to you all. Thank you very much for joining us. In the technologies you represent, there's a mix of the old with the completely new in wind power, batteries, fuel cells, and atomic energy. They've all been around for a while. Aeons, of course, almost in the case of wind, and many decades for the others we have here today. But in talking to our panelists, in the preparation for this, one of the quotations that stood out, and thank you, Mikal, that I thought pertinent, was his view that we're talking SpaceX versus Apollo. Certainly with respect to atomic power. One of the things we need to do, perhaps, is to demolish preconceptions or misperceptions about the potential for these new technologies and about the reality of risk to make sure we're able to seize opportunity. So let's seize opportunity when it might be staring us right in the face, as we all are staring at each other today. How different will our ships of the future be? Most of us in deep sea shipping are used to the idea that bulk carriers, tankers, and container ships have one big 2-stroke engine and 3 or so little generators to provide the propulsion and energy. Things are changing, and of course, smaller and specialized ships have different needs and operational requirements. So we've seen growing demand and interest in electrical systems providing hybrid power solutions. But we probably mustn't pigeonhole technology and propulsion systems as just being suitable for certain ship types or specific markets. So let's look at the potential for these alternatives. I've asked each of our CEOs to give us a quick initial perspective on how they see the landscape from their desks, from the perspective of their technology. So if we go in program order, let's get into it. Please can we start with you, Kim? Over to you. Thank you.
Okay, thanks a lot, Nick. Highly appreciated for the introduction. I was also very, very pleased to be on the panel here today. As mentioned, my name is Kim Diederichsen. I am the CEO of Anemoi Marine Technologies, a British supplier of rotor sails. We've got our head office in London, test and training facility up in Blythe near Newcastle, and our production facilities in China close to the Shanghai area. I believe that the panel here and the rest of the audience is quite familiar with rotor sails, and have heard of rotor sails, also known as Flettner rotors, which were first installed back in the 20s for the first time. At that time, they weren't widely spread out and commercialized, simply due to a fact that the cost of fuel was low and the cost of the system was high. However, today, I would though say 100 years later, things have changed. There's an increasing interest in wind propulsion, and especially in rotor sails. And we at Anemoi believe that rotor sails can and will play an active role towards decarbonization of shipping. And if I should give a couple of reasons why we think so, then these could be tied to the fact that rotor sails, as of today, they are available. And they are very well suited for both retrofit implementation, but also for new build. The TRL level of rotor sails is high, and the technology as of such is considered proven. And the technology can very well be combined with any other energy-saving technologies, or later on fuels when they're available. So in conclusion, we believe that rotor sails support owners meeting the current and future regulations. I'm thinking of EEXI and EEDI. So rotor sails are spinning mechanical cylinders that harnesses the power of the wind to produce thrust and thereby assist the propulsion of the ship. That increased propulsion can either be used to increase the vessel speed, but more likely to reduce engine power and thereby reduce fuel. That reduced fuel consumption has directly and is directly linked to the reduction of emissions as well. And subject to system configuration and layout and vessel trading pattern, etc., we often see reductions in the magnitude of 5 all the way up to 30%. So we at Anemoi, we are working quite hard to unlock the technology and secure a wide adoption across many, many different vessel segments and classes, amongst others, within bulkers, within tankers, ro-ros, etc., etc. And if I should give you a quick summary of some of our activities, they would include the launch of a scalable rotor design that has resulted in a wide range of products and sizes to suit the most vessel sizes and deliver maximum performance for each system installed. We are also launching a number of deployment systems, which are the ways that the systems are deployed. It's the fixed system where the rotors can either be fixed mounted to the deck, a folding system where we can actually fold the rotor from the vertical to the horizontal, or even a rail deployment system where we can move the rotors transversely or longitudinal on a rail system on the deck. And another thing, if I should give a quick introduction to the rotor sails, is they have a lifespan of 25 years, and the rotors can be moved from one asset to another, so from one vessel to another. So they are redeployable. I think it represents a quite interesting value proposition for owners going forward when installing such type of technology. In order for us to increase or to support that increased demand that we're currently seeing, and we are increasingly seeing demand for rotor sails, we're currently scaling up production and activities both in the UK but also in China. So we support a wide range of clients currently, and I see, and what we foresee, that technology here, that wind technology of rotor sails, we foresee an uptake and rollout as of 2022. So as an introduction to this panel discussion here today, I can say that we at Anemoi believe that rotor sails can and most probably will play a role when looking at decarbonization of the shipping industry. Over to you, Nick.
Yeah, thank you, Kim. That's great. That's great to get us started. I will pass the baton immediately to Mikal. Slightly different timeline, I think, from you probably, Mikal, in terms of actually being ready to introduce it, but you're working very hard now.
Thank you. Absolutely. So I think just frame this rather differently than introduce you to atomic technology and try and explain it at this forum. I think it's not the right forum to do that. But if we're thinking about a 30-year line in front of us, right, we've got a massive challenge. I think Bill Gates has been going around saying, with two numbers we need to care about: 51 billion, which is the amount of carbon dioxide and greenhouse gas emissions that we pump into the atmosphere every year, not just in total, but every year. And the number zero, as I built it, zero as a concept where, we've got to get rid of this. And if we do this, we have to zoom out. We have to zoom out and we have to think of this in a slightly different way. We have to think of this with a different, if you like, hat on than the one that we used when we got here in the first place. So yes, we can reduce emissions, doing all sorts of things, which of course we have to do. We have to be more efficient. We have to operate more efficiently. We have to find ways of doing things so we produce less waste. I mean, that's progress in any case, right? But I think what we have to do, if we're going to look at this, we have to look at it as an existential thing, right? So if we accept, and some of us don't, and some people quite rightly question, everything that happens, and that's, do we have to go to zero? But let's say we had to move as close to zero as we can, and we look at, from a very high level perspective, where does energy come from? I mean, what is it exactly, and how do we use it? We can then look very specifically at, things that we do at ship level, shore level, in the entire supply chain. We can look at the well to wake. We can look at, the life cycle of all of these technologies. If you're going to have huge amounts of solar panels, well, you're going to need huge amounts of metals and silver and glass and all that sort of thing. But if we zoom out and we say, where does this energy come from and how can we harness it? And you zoom all the way back to the Big Bang, you're effectively looking at, where this all comes from. And it's in four distinct categories. You've got energy coming through, our elements, which are formed in ancient star systems. You have the heavy elements, heavier than iron, and you have those that are lighter than iron. And then you have our sun, which produces, an enormous amount of energy through nuclear fusion, which of course gives us wind, which gives us solar, and which gives us rain, so we can have hydropower. And then you have the third energy system, which is also powered by the sun, which gives us photosynthesis, which provides plant life, which then becomes ancient, and we use that as fossil fuels, or we can burn those through biomass. That is the part of the energy system that we're struggling with now. The one that comes from sun, photosynthesis into plants, which we're now burning in some sort of way. We're burning them, we're putting that back in the atmosphere, and a lot of people are saying, great, we can sequester that back into plants, but it takes a hell of a long time. You're talking 100,000 years before the final bits of that carbon is sequestered back in the industry. If we then move across to the other energies, we look at wind that comes from the sun effectively, water that comes from there, and we look at solar. And that's where we have to focus our attention, but we cannot get all of the energy we need from those. There just isn't the technological capability of soaking up that energy or even multiplying that energy. So we need to add the last element here, which is where we're using our elements, where we're using atomic energy, the base energy for all of this, in a way that adds to the system. And to do so, we need to think different. We need to think about the way that we approach this. And we have to realize and recognize that in the early days of technological development, we make a lot of mistakes, right? So back in the Second World War, nuclear was only one thing. It was the most terrible thing that we can all conceive of. And that is in the mind of people still, this link between nuclear as a weapon system, nuclear as an energy source. And a lot of people struggle to break those two apart. So just to sort of conclude this introduction to why we need to think differently and why atomic has to be a part of this. And I think we do a great disservice to ourselves and future generations if we don't do this, is that we have to recognize that the early mistakes of nuclear energy, which is distinctly different for anything to do with nuclear weapons, have largely been solved. To be fair, nuclear energy reactors that produce electricity haven't killed a single person from radiation on this planet anywhere since 1986. Now, you compare that to anything else, that's a pretty good safety record. So we've learned a lot. But what we've got is an inefficient system which was built in the 50s, built and designed in the 50s and the 60s, and is still being built and designed today. New reactors, big power plants being today, still the same reactor designs that were conceived in the 1950s and 60s. What we've got is in front of us the opportunity to create an energy system based around what we like to call advanced atomic. And that's where your Apollo SpaceX metaphor comes in, Nick, where, you take the 1960s rocket technology, 50 meters of hydrogen peroxide and a couple of people sitting on top of it, flying off into space with the computing power of a pocket calculator versus what we can do today. So, we're working specifically with the US, funding from the US government, with very strong partners in the US to build the first of these new advanced energy systems. And they're different, right? These are orders of magnitude safer than even nuclear as it is today, which is actually proven to be one of the safest energy sources that we have. But, safety is of paramount importance, and we've got that. Then we've got that fuel efficiency. The fuel efficiency that goes from, very low fuel efficiency, although the energy density of the fuel is very high and gives us a lot of power with little waste. This is now moving to the other end of the spectrum and giving us much closer to 100% fuel efficiency, of course, never quite getting there, 95, 96%, leaving very little waste indeed, using up pretty much all of the energy that's there. And then being able to do that at small scale, not massive, multi-gigawatt grid scale, but at small scale, which means that we can mass produce them and we can deploy them in heavy industry and heavy transport in order to provide truly zero emission technology. Now, you're not talking about, not emitting carbon dioxide, you're talking about not emitting anything at all. I mean, there is nothing, no zero. Nothing comes out of this. We think this is best deployed initially as a way of producing the synthetic fuels that we can use in current technology. The fuel cells that Vasilis and Geir are working on in combination with wind technology like Kim is working on, to provide really a transitionary system that we can use. This could be green ammonia, it could be green methanol, it could be synthetic LNG, it could be all sorts of things, but you're using a clean energy source to create these things. And then gradually, as we accept, as a people that we need to move in this direction, we could start then looking at how this can power ships directly. Of course, there's lots of hurdles to get there from where we are today, being fearful of nuclear and, the scare in ports and sort of people remembering all sorts of things that happened with very old technology that's not relevant to this, but, we need to get there. So, then if we get to that point, we've got an opportunity. I'll give an example, right? So you've got a Cape-size bulk carrier running iron ore from South America up to North Asia, about 60-day round voyage. You would use about 1,100 grams of fuel on a round voyage here. So if you multiply that up, 1,100 grams of fuel, that's the total. That's also what, effectively what you have as spent fuel. So it's 1.1 kilos, 185,000 ton vessel. And then you've got, multiply that up at full, utilization for 25 years, the lifetime of the ship, you get to just shy of 200 kilos of fuel. 200 kilos of fuel at a density of 20 to 1 versus water, you're talking about something the size of a briefcase. That's decarbonization, right? That's where you use energy intelligently, smartly, and with a way in a way that says, we're not leaving a footprint here. This is sustainability, I think, as close as we can get to it. So atomic, wherever you think of it, whatever your previous think of it is, has to be part of it.
Mikal, I'm going to stop you there. That's a great start. Thank you for that. Let's take Geir next. Corvus Energy, you're active in batteries and fuel cells. And I'll come back to a lot of what you've said, Mikal, I think, and we'll bring that in. Geir.
Thank you, Nick. And thank you for the organizer to inviting us to be part of this. A little bit about Corvus. Started in Vancouver, Canada, 2009. And we moved the headquarters to Norway in 2018. And we have production facilities for maritime batteries currently in Bergen, Norway, and in Vancouver, Canada, and have a global sales and service network, and we are around 145 employees. And our team consists of people with a superior deep battery knowledge and with people with a strong maritime DNA. So we are only addressing the ocean space when it comes to energy storage system. As you correctly also mentioned, we are also recently announced that we're also entering into the fuel cell space, and we have signed a collaboration agreement with Toyota to develop hydrogen-powered fuel cells for the maritime space. But what I like to say, of course, that we have as our mission to power a clean future. So we like to be in the battery and also in the fuel cell space. Since 2009, we have been delivering and have on the way to be delivered more than 400 different 400 ships. And this is also not only small ferries or supply boats. We have everything from the Suezmax tankers. We have units on board big container ships. So, and also when it comes to this content of that we are not say it is not a zero-sum game. Batteries is a part of all these kind of new alternatives. First of all, that you make it optimize the current system, and we see that the battery is in hybrid increase the efficiency and reduce the fuel consumption in most of these cases, and especially in the cases where you have gensets and the number of gensets and installed power is related to redundancy more than the power need at time, like in dynamic position application. This is that battery can be there as a spinning resource. We also then together the batteries together with reciprocating engine or fuel cell, all kind of types. We will dramatically also reduce the running of all the engines that today are idling just because they're going to provide power in the short notice. And of course, then you also can use the battery in a very traditional propulsion plant to balance and to do load leveling and peak saving. You will batteries also in those applications increasing safety, because you will avoid blackout situation. I think that's because the batteries that you have on board is like big UPS in these cases. And also the good thing that we can say also why now we are see an increasing uptake of battery to all kind of vessel types is that what we call the batteries are in the money. We see that the business cases have very short payback time, even on retrofitting on existing vessels. And especially we see that, okay, one thing is the portion that you're reducing from saved fuel, but we see in many cases actually the contribution from reduction in running hours and maintenance costs is contributing greatly to such a business case. So batteries are there, of course, for fully electric operation where you can fuel several times a day, like typical double-headed ferry if you do charging in these days, but also up to we see now with the new battery types, you can also have big batteries on board that you can fuel, you can charge overnight, and you can operate a whole day. And also we see fast ferries. So we therefore have developed from being one battery kind of company. We currently have 7 different types, from the very lightweight for high-speed vessel to batteries that can be used subsea. We also having battery on the charging station for ROVs on the sea bottom. So that will I just round up and say that batteries are an enabler for a lot of these, all of the new technologies, but also are a huge contribution to reduction in fuel and cost, also on a traditional propulsion system. So thank you.
Okay, super. That's great, Geir. Thank you. To get us started. So Vasily, last but certainly not least in the introductory phase.
Thank you very much. It's my pleasure to be here as well. This very esteemed panel, and I really mean it because all the other companies also, making stuff, and actually they pushing the envelope of all of this. Because as you said in the beginning, with the new fuels, we're going to have new engines as well, right? So we have to see how we're going to change it and how the new things that we bring in compared to the combustion engines. So Advent is a NASDAQ listed company. We develop, manufacture, and sell fuel cells. It's a particular thing we have actually invented, the high temperature PEM fuel cell. We have about 120 patents on it. We've started from stationary applications. We're now trying to move to automotive, also aviation, and marine, even though it's the most difficult because of the sizes that the industry wants for main propulsion, even for auxiliary engines. We have a solution there, and I'm going to spend a little bit of time to explain it. The idea here is that the fuel cell is an electrochemical engine, it's not a combustion engine. So basically it has good things like a very good efficiency, about 60%. And actually also it has lower noise, lower, of course, emission, depending on the fuel used and all that. Now, the key point, the key differentiator of Advent compared to other existing technologies is that, and we have any fuel anywhere, which means traditionally fuel cells are associated with hydrogen. And hydrogen is, you know, it's very important. We think in marine, it could be an issue, mostly things that we've discussed already before in terms of mainly safety, you know, how to handle it in a vessel. And in our opinion, because we're going to have multiple solutions, Mikal said that, I mean, even in the auto fleet right now, okay, we have diesel cars and we have gasoline cars. Of course, you can imagine, you know, in the future, because this is a 30-year race, if you will, there will be solutions that are better for a particular technology versus another one. We work, as also Geir said, very close with the batteries, because in reality, the batteries will prevail. On the other hand, they have very low energy density. They can do certain things, so they need the fuel cell to take them to the next level. Of course, you know, that could be also with the wind assistant propulsion and everything. So in reality, what we think is going to happen is that there are few, you know, projects right now that are running with different fuel cell technologies. A lot of them in Europe. I think the next 5 years we're going to see things that we didn't have them before. Right now, you know, fuel cells are kind of in the infancy, but you know, 2025 comes, you will see a lot of attempts. You will see a lot of vessels, you know, experimental vessels, obviously, but they will have different kinds of technologies up. And again, it will depend on the life cycle of the, you know, of the operation, and also the power needed. Okay, because for different powers, you can use different fuel cells. For us, as I said, we believe a lot in methanol also as a fuel, because we feel that the transition to, let's say, a hydrogen economy or a hydrogen propulsion one day for fuel cells, you know, granted that all the other things that have happened, will go through some kind of liquid cells or even, you know, natural gas and everything. So in the end, these technologies are scalable. We feel there's going to be a lot of activity here. And our particular technology, the high temperature PEM, works with a lot of different fuels. So we think we're going to have a lot of success in the marine as well. Knowing that it's a very difficult field because we're talking about, you know, big engines, if you will, or big powers. So thank you, Nick. I'm very happy to take then question. We go to the question session.
Super, Vasily, that's great. I mean, what I'm hearing, you know, potentially is that you could have a ship that takes methanol that's been produced by atomic power generated by, you know, Mikal's system. It's supplemented by Anemoi's rotor sails to provide additional thrust. And Geir, your batteries would smooth everything out and make everything more efficient and give you flexibility, potential redundancy, overall optimization. How far away are we from that kind of ship being, you know, in a shipyard anytime soon at reasonable scale? You know, I mean, in terms of the fuel cell, if that is effectively the main engine.
Yeah, I think Mikal said that these are all government-driven decisions. You know, the minute you take a look at the regulations, you have to change the tech. So the tech has to be even better, and we're working on it every day, meaning that we know where we have to be. It's just we're working towards that, meaning A, efficiency. Okay. Second, longevity. Third, cost. So as you can imagine, the first vessels will be very expensive, but they will make the case. Then in some better applications, they will be self-sustained. And in others, they're going to be in conjunction with all the things that you said, because I do believe in the end, it will be a combination, because in order to get these new regulations, you have to move away from the old, which I think is very difficult, because most of us, even us, you know, we were the pioneers, if you will. Deep inside, we're all conservative people, meaning that we understand what we understand, and we go to the next thing only when we're forced to go. And now I think the whole idea here is that there is a tremendous force to change. And by changing, as I said before, the fuel, you kind of change also the way that you operate. It's not only the combustion engine that will dominate, you will bring all the other technologies in. So it's feasible, it's happening. There are about 10 European projects and a couple of projects in Asia that they have these demonstrators on. And I think the more we will see more and more of these things, because in my opinion, it's a one-way street. We're not going to go back.
Yeah. Okay. And Kim, I mean, you're very busy at the moment, putting your systems on ships, you're getting ready to put them on. I think you're busy for quite a long time out now. If anyone wants to come to you for an order. I know you don't really want to talk about the regulatory landscape, but
but it's correct. I mean, the fact is that what's happening right now, and I'm very sure we all see it, the increased regulatory landscape, as you say, and the requirements in order to comply here, especially for the existing fleet with EEXI, means busy days here at Anemoi. So we are really trying to not only help them here, but also find solutions how we can accommodate this. If I should address it, I would say that demand for rotor sales will increase here over time and exceeding the potential supply. That means that the demand for rotor sales when rolling out here after pilot testing and really rolling it out for fleet implementation, that require different ways of doing it. And we have implemented one thing, and we are implementing one thing. It's called Wind Ready. In order to accommodate this, Wind Ready is an option for vessel owners having dockings now and coming soon to prepare the ship in the shipyard. That means every work related to the integrational work, everything's beside the physical installation of the rotors, can be done now, preparing for the years to come. Why? Simply because rotors can be fitted and mounted following as you go. So right now there is a production limitation of rotor sales in order to comply, or let's say feedback to the demand that we are seeing currently. So we're working a lot with vessel owners right now to plan this out from our side. So I think 2020, late 21, 2022 is going to be very busy for us. That's what we
just quickly, why rotors rather than a sail type system? If you're going to
I mean, very, very simple. So if we look at the projected area of a rotor, simply by taking the width of the rotor and take the height of the rotor. So if you took 1 square meter of projected area of a rotor, it roughly, big picture, roughly has a magnitude of 10 times more efficiency over a conventional sail. So it's a factor 1 to 10. So these mechanical sails, despite that you spin them up, that you use energy to spin them around, the net output is roughly 10 times more than a conventional sail. That's the reason why. And then, of course, it has the space limitations. It's feasible to install them on many, many different types of vessels. So if you can, in addition to that, bring them away out of the operational zone while doing cargo operations, if you can move them away, either lay them down or anything else, then suddenly it becomes practically also in real life operations. And that is in the marine industry, of course, key essential so that we can avoid any port delays and optimize ship operations. So this is what we're working at constantly.
Okay. And one of the themes this morning in Martin Stopford's presentation, in addressing how the industry is going to make the most of existing ships and also be in a position to afford and operate the ships of the future, that came up is retrofitting. You've talked about Wind Ready. Geir, is a shift to electrification something you can do with existing ships easily, or is it really new ships you're talking about?
No, we have done of those 400 maybe 50-50. I think of course if you have an old vessel with straight mechanical propulsion, the business case is not so good as if you have already a quite modern diesel electric. So you see almost every platform supply boat done so far is a retrofit, because you have a huge fleet of modern vessel already diesel electric. But we also see now that we're working on even bulk carriers to put on batteries there to regenerate, for example, from the cargo operation, from the cranes, and also being spinning reserve if they are boat thrusters, and also that you can have load leveling and reduce the number of running hours on the genset. So here we see that you can do on a retrofit, and you will see on new building, but business case is of course better when you have a fully electric ship, and therefore also, and of course, if you have a very high value ship, so we are putting a huge system of 10 megawatt hours on a cruise liner. Of course, those are very expensive and going to last for a long time. But so that's but you can do it on all kind of ships, and also old one.
And just quickly, is one of the attractions for the cruise ship operator to have much more silent and clean operations while in port?
Yeah, this is mainly for clean operation in port, and also in restricted area, like you see now in some of the fjords. We're talking about that you have to be zero emission operations. So there also that you can do that, and of course also that you use the batteries for for safety, like a big backup. So we have cases where we had a blackout on cruise liners that you could avoid, and of course that to load leveling and for spinning reserves in a normal operation. So you have many reasons to put a battery also on the cruise liners.
So for example, if a cruise ship had a total blackout, in some dangerous waters off Norway, as we saw, recently, having that reserve might be useful to be able to get out of trouble quickly.
Yes, because depending on the size, but like for the AIDA cruises where you put 10 megawatt, then you can operate for quite a long time on the battery. So you would be able at least to have some time to fix the problem, or to lower the anchor in the safe spot, or at least so that it will increase the safety. Without me, I don't know anything about that specific case that you're referring to, of course.
I'm sure.
So, but in general, yes.
Okay, thanks, Geir. And Mikal, I mean, how soon before Vasilis methanol powered fuel cells could be, benefiting from cheap e-fuels generated by atomic power, or how fast could your system be in a big bulk carrier, for example? What's your timeline?
I think the first question is the pertinent one. It's hard to say at this point. I mean, we're aiming to have this done this decade, so before the end of the 20s, that you have a durable industrial scale system creating, creating a number of things of a floating platform. It's important to recognize that something like this is agnostic, right? So, if hydrogen turns out to be a bit of a dead end, if ammonia turns out to be a dead end, I mean, we just don't know what the various technologies that we've developed are they going to be acceptable? All the various drawbacks you get with hydrogen-based fuels, etc. In a sense, we're completely agnostic to that, because effectively what we do is we provide electric power on an enormous amount of industrial heat, and this can be used for so many things. You can use it to turn seawater into green hydrogen very efficiently. You can take that, you can turn it into green ammonia, you can turn it into green methanol, you can turn it into any number of things. We can desalinate water, we can provide electric power, we can charge batteries, we can, not exactly make the wind blow, but we can do a lot of things in the background here that I think are quite good. So really, I just wanted to, because I know we haven't got much time left, but I just wanted to, insert one key point, I think, and you were making a point about this, Nick, and that's, look, if the only driver of this is regulation, then just like in the banking industry, we'll all find ways of getting around it, right? It's got to be, some way of complying. It becomes a compliance game. And we get to a certain target and we say, okay, fine, we met those standards, fine, let's just carry on as normal. If we've actually got a case here where, that's backed up with the kind of penalties that, for example, Trafigura is asking for, as they're looking for carbon taxation, and many people are talking about this, we're the biggest supporter of this, of course, because it's a great, supporter of our cause, with no emissions. You start to level that playing field a little bit. If it really is a question of retrofitting, technology that, makes improvements on existing technology, then it's a question of payback. I think really what we're looking at here is something that, creates a brand new way forward. If you've got a self-powered, fully electric floating production plant that turns, seawater and air into synthetic fuels, and you can do that where it's needed, you can scale it, you can move it, you can create flexibility around its demand following, you can do it without any emissions, and you can do it in a friendly way, mass produce with components from around the world, etc. You're looking at a brand new energy system. That creates a new competitive advantage. That creates new products. That creates new markets. That creates new ways for owners that are probably listening right now to say, well, actually, I could deploy my capital in markets which are not just moving coal and grains and iron ore around. And I think that's the exciting part of this. It has to come from innovation, Nick. It has to come from the kind of things that these guys are doing and we're doing, which is building new things that can create new advantages going forward, not just by politicians saying what they want.
Well, thank you, Mikal. I mean, I think that story of innovation sounds really exciting, and it's certainly starting to look like an industry that's very different from the one I started in. Nicholas is back. Thank you very much to you all. We just haven't got enough time to talk about this. It's really exciting. Someone this morning said, who wants a big two-stroke diesel engine anymore? That's a problem we have to get rid of. Well, I'm not sure that's been fully decided yet, but I think certainly, we clearly have a lot of options for the future going ahead, and it's going to be, really interesting to see what happens. People who think 2040, could be really different, I think may be surprised by just how different things are in 2030 or even before then. So thank you, Nicholas, for the opportunity. I know you want to close this off and get us on to the next session, but thank you, Kim. Thank you, Mikal. Thank you, Geir, and thank you, Vasilis.
And thank you
Thank you.
to everybody. Thank you.